YouTube. There we go. Now that's working. Everything's doing good. Number 2 is what we say now, right? Is that the flow of life, love, and the pursuit of happiness? I love it when churches are trying to be edgy and they're like, we believe in life, liberty, and the pursuit of holiness. Like, okay. Okay, bud. We know that you think you're better than everybody else, but calm down. Calm down. 3 2s, that sound reasonable? Number 2, you. Okay, here we go. Oops, I turned too far. Try again. Number 2 is 94 degrees because of alternate exterior angle theorem. Number 4 is 101 because of alternate interior angle theorem. Number 6 is 79. These are all degrees, of course, because of consecutive interior angles theorem, which is the same as same side. And totally fine. Number 8, x equals 125 degrees by the supplement theorem. If you put linear pair, that's fine. Y equals 125 degrees by the alternate interior angle theorem. Number 10, x equals 70 degrees. Well, it's x, so it's just 70 by the alternate interior angles theorem. Number 12 is 62 because of the corresponding angles postulate and the vertical angles theorem, or the alternate exterior angles theorem. Number 14 is 62 because of the vertical angles theorem. Number 16 is 80 because of the alternate exterior angles postulate and the supplement theorem. Most of these ones that are like 2 things, there's other ways to get there. So your justification may be different and still may be right. That's possible. Excuse me. Number 18 is 80 because of the vertical angles theorem. Number 20 is supplementary, excuse me, because the consecutive interior angles, again, that's same as same side. Number 22 is congruent because of alternate exterior angles. What did we go to? 30, right? Yeah, great. Number 24 is in the answer appendix. Let me turn the page. Okay. 24, y equals 114 by the corresponding angles postulate, x equals 54 by the supplement theorem. 26, x equals 63 by vertical angles theorem and the consecutive interior angles theorem. Number 28 is x equals 54 by the alternate interior angles theorem, y equals 12 by the consecutive interior angles theorem, and 30 is a proof, so we can go over it if and when you need it. So before we look at 30, did we do 3-3 as well, or just 3-2? 3-3 as well? Okay, 3-3 is the easier one, right? That's just slopes and stuff, slope formula. Okay, so other than the proof, do you have any questions on this one? 28. Okay. Have my markers out of the box. Well, these markers are dying. It's almost time to go to Sam's and buy a new thing. Or is it Costco? Sam's, I think. All right, 28 has got a picture that looks more or less like this. And it has labeled that this and this are parallel. This one is 5y degrees. This one is 2x degrees. This one is 120 degrees. And this one is on 108. 108 degrees. Later on, we're going to learn another theorem that's you could actually use on this particular problem, but we don't know it yet, so we got to use what we got. So we need to find x and y, right? How do we do that? What can we use? Did you say geometry? Oh. We're probably going to use the 108 somewhere. We're probably going to use the 120 somewhere, right? The which one for y? Yeah, the 120 we can use with y. That's true. Okay, so let me plop some kind of colors on here a little bit. So this guy and this guy, what are they? Consecutive interior, right? Same side interior. That's true. That's right. So how are those related? Why do I call it same side instead of consecutive? Because they're supplementary. What does them being supplementary mean? Yeah, they add up to 180. So what kind of equation could we write? Five what? 5y, right? And then what about the 120? How do we get to 180? Are we multiplying or adding? Adding. So 5y plus 120 equals 180. That's an easy peasy equation, right? We've been doing that since junior high. So what do we do now? Subtract 120. What's 180 minus 120? Yeah. 160. Not 160, but just 60, right? Well, yeah. Yeah, you're good. You're doing great. Thanks for the response. Now what? Divide by 5. So y equals 12. Right? Okay, now how can we get to x? Yeah, with the 108. That's true. So those two, grab a different color. This one and this one. What are those? They're actually not nothing, right? Because we've got, remember, if you're having a hard time seeing it, you can extend out these lines, right? So are they exterior, interior, or both? Let's start with that. The parallel lines are this way. Are they inside of the parallel lines, outside the parallel lines, or both, or one of each? They're both inside. Okay, great. So they're both inside. So are they same side or alternate? They're alternate. So they're alternate interior angles, right? So how are alternate interior related? No, remember what I told you yesterday when you were asking me about that. Nothing's complementary. There's only two options on these. They're either congruent or they're supplementary, right? They are congruent. Getting those words mixed up. So they're congruent. So what equation are we going to write? What? They're not supplementary. They're congruent. What does congruent mean? They're equal. So what is that equation going to look like? Mm-hmm. 2x equals 108. Now what? We divide. Yippee. That's true. All right. Any other questions other than the proof on this one? Okay, so we're going to do something a little bit different. I'll take a question on the proof. Oh, you have something? Okay. Can we do 8? Yes, we can do 8. All right, so number 8 has got a couple parallel lines that look like that. We have y degrees over here, x degrees over here, and we have 55 right there. 55 degrees right there. We're supposed to find x and y. Explain our reasoning. So what can we do? X and 55, what are they? They are a linear pair. That's true. They are a linear pair. How is a linear pair related? They're what? No, they're not congruent. Vertical angles are congruent, right? But a linear pair is not congruent. You can even tell just by looking at it, right? If we draw one, those are definitely not the same, right? Right? How are they related though? They're supplementary because a straight line is 180 degrees, right? So those two adjacent angles are supplementary. So these two are supplementary, so how can we find what the value of x is? Not 90. 180. And then subtract 55 both sides. And you get x equals 125. Right? Those x and y, how are they related? They're interior, they're what interior? What? This different A word, you probably mean the right thing. Alternate interior, right? Now, alternate interior. So alternate interior, how are they related? No, they are congruent. I don't know why I'm shaking my head. I don't know what I'm doing. You're right. You were 100% right. You were totally correct. So they're congruent. So what does y equal? 125. Easy peasy. All right. So we're going to do something a little bit different. I suspect at least one of you probably wants to look at the proof, but make sure, I will throw this out there. I feel like I've said this before, but I cannot stress it enough that when you have a proof in your homework, try it. Put something. Don't leave it blank. Don't put a question mark. Don't put IDK. Try it. Because if you're not trying to think about it, then you are never going to get better at it. That is 110% true. It's never been more true in math. Okay? It really, really hasn't. So make sure you are trying it. But I'm going to go ahead and get the things, go ahead and give you the answers on 3-3. And then we can, if we need to go back and hit that proof, if we have any questions on this, we can do that. What numbers did we do on 3-3? 12 through 32. Okay. Unfortunately for our time, I bet if you have a question, it's probably on 32. But that's all right. Okay, number 12 is 6/7. Number 14 is 0. Number 16 is -4/5. 18 is 0. 20 is undefined. 22 is 3/4. 24 is -11/8. 26A is a graph. We can look at it more if you have a question on it. a straight line looking like labeled with lactose. No, lacrosse. Lactose. But all the lacrosse players are lactose intolerant. Gavin, every time I look at you, I think that is a super cool color of a shirt. Nice. I like that shirt. It's cool. Even, I mean, it's boring. It's like one color, but it's a cool color. So anyway, moving on. 22 is 3/4. No, I was already on 28. 26. 26 B is 8,500. 26C is 244,000. 28 is parallel. 30 is neither, and 32 is perpendicular. What questions do we have from that lesson? Sixteen is a picture, so let me grab my thing and we'll put it on the television. Oh, I didn't just turn it off. Let me grab it from your book because it's bigger. Investigating slope. Okay. Where did the TV go? Oh, maybe I did turn it off. Now we gotta wait for it to show up. I don't know why it takes an hour and a half. There it is. Oh, why didn't y'all tell me it was waiting for me? I was watching American Pickers. All right, so we're supposed to find the slope of this dude, right? Slope of that one. All right, so what I always tell people is you need to count from across to across. Now, however, having said that, in this particular problem, they give us points to count from, right? So we don't even have to find where the crosses are, right? They give us points to count from. Right, so to go from M to N, are we going to have to go up or down? Down. So our slope is going to be negative. Start at that. It's also going down and to the right, right? That we can tell just by looking, right? We don't even have to do the math to figure out that it's negative, right? So then we're going to go down. We're going to have to count down how many? 4. Then we count over how many? I didn't count 4. 5. So negative 4/5. Done. Easy peasy? Yeah? Any other questions from this lesson? Y'all are good on all of it. You got 28, 30, and 32 all completely correct. You didn't have any problems with those. What? No what? No you didn't, or no you didn't have, I don't understand. Do you have a question on those or nah? You don't have a question on those. Because I'm going to tell you right now, there's one of them on the test. I can tell you that right now, for sure. $30 just in case. Okay. $30 says with the given points, to figure out whether lines AB and lines CD are parallel, perpendicular, or neither. What are we looking for to see whether they're parallel, perpendicular, or neither? No, they are lines. What are we looking for about the lines? Right? If they were parallel, what would be true about them? Right, the wrong one, aren't they? They would be what? That's true. The lines would be not touching. That's true. No. What is this whole lesson about? Slope of lines. That's what the name of the lesson is, right? So what's true about parallel lines and their slopes? They're the same. That's right. What about perpendicular lines? Yeah, they're opposite reciprocal, right? It is actually the inverse. It's the multiplicative inverse. So you accidentally said the correct thing. Okay, so how do we find the slope between A and B? Yeah. Slope formula. One minus two, you're right. Over what? So what's 1 minus 2? Negative 1. What is negative 3 minus 4? Negative 7. So what is the slope? Got a negative divided by a negative, so what's that going to be? Positive, so positive 1/7. No, 1/7 and 7 are not the same thing. You can't just magic it back over. If it was 7 over 1, then you'd be right. It'd be just 7. But it's 1 over 7, right? So the slope between C and D. What do we do to find that? A minus 0. And over what? That's a 10, but yes. You might have said that. Did you say 2 or 10? Okay, great. I heard you say 2. I don't know, Mia. We need to teach these boys how to not mumble so much. What do you think? All of them except Aiden. He probably mumbles too. He just doesn't do it very often in here. What's 8 minus 0? And negative 10 minus 6? Negative 16. What now? Reduce. 4/8, which can go even further. We can actually reduce this by 8 even. Even further. 1/2, right? Negative 1/2. So, are they the same, or are they opposite reciprocals, or are they neither? They're neither. They're nothing. All right, have y'all seen the video of the little kid in the car. He's talking to this person on the street, and for whatever reason, the kid is like, "Mom, is that a boy or a girl?" And the person's like, the kid's like, "Are you a boy?" And he's like, "No." "Are you a girl?" "No." "Oh, I'm transgender." And the little kid's like, "So you nothing?" And he's like, "Yep." And then the little kid's like, "You a crackhead?" Like, oh my gosh, child, that's crazy. So funny. Kids are funny. They say funny things all the time. All right. Any other questions? Do we need to look at that proof? Probably. Okay. Isn't this a fill in the blank one? Yeah, it is. It is. Let me, since I've already got that loaded, why don't I do it up there? Then we can fill in the blanks. I'm gonna take a picture of your thing again. Here we go. This one I will flip the camera around for. You were the chosen one. That's funny. That's funny. Let's see if I can zoom in enough to where we can see stuff. Well, that's annoying. Because when I do it to where I can see everything, you can't see everything. All right, I think that'll work. Good enough. Okay. All right, so there it is. What is the number one, the A blank? That's gonna be the easy one, right? What is that gonna be? Yeah, so you're just gonna write out the given. So just take all of this stuff and write it. All right, that's easy peasy. All right. So the next one, blank B. Angle 1 and angle 3 form a linear pair. And angle 2 and angle 4 form a linear pair. Right? So what would be the justification for that? What? So no, not vertical angles. I know that those are linked in our brain, but that's not what that would be. How do we know? So it's saying that angle 1 and angle 3 are a linear pair. How do we know that? Yeah, because they are, right? What is that? We talked last time, I feel like one of the last times we did a proof, we went all around that. If this thing is that thing, what is that? The definition. So that's easy peasy, right? So this is true because of the definition of linear pair. All right, easy peasy. Okay, so if the justification for part C is if two angles form a linear pair, then they are supplementary. What is that the justification for? That's a supplement theorem, right? So what does that mean? What does supplementary mean? At 180, which they give in the, no they don't, just kidding. I don't like the way the book wrote it. That's weird. Okay. So, add it to 180. So what would we write? What would we write in blank C? One, not 1 and 4. Which ones are linear pairs? What did part B say was a linear pair? 1 and 3. So the measure of angle 1 plus the measure of angle 2 equals 180, right? And then the same thing for angle 2 and angle 4. Measure of angle 2 plus the measure of angle 4. I don't like the way they did this proof at all. They're like missing a whole step, really. It's fine. They said part C was that angle 1 and angle 2 are supplementary, which is what we said too, just with the math part. which doing it, yeah, I don't know. They just did something, they did something silly. Okay, so angle 1 and angle 4. So angle 1 is right here, and angle 4 is right there. What are those? A different A word, but you're on the right track. Alternate, right? Yeah. Yeah, you meant the right thing, right? So alternate interior angles. So this is saying that this is congruent to this and this is congruent to that, right? Because why? What did we just say? Because why? Yeah, the theorem. What was it called? Alternate interior. I'm looking forward to grading your test later because I'm going to have to decide, do I count off because he said adjacent interior angles or not? What? Yeah, I might not know. Yeah. Okay. Angle 4, the measure of angle 4 is equals the measure of angle 1, and measure of angle 2 equals the measure of angle 3. It's the definition of congruence. They just turned these things from congruent to their measures being equal, right? So let's see, what are we even trying to prove? We're trying to prove that they are supplementary. So what can we do on this last line? Are supplementary. Cohesion, you're a cohesion. So measure of angle 1 plus the measure of angle 2 equals 180, right? So they're supplementary. We'll do the same thing for 3 and 4, but what lets us do that? It's not transitive property. It's like the transitive property, kind of. We're just substituting. That's all we're doing. Yeah, we do the same thing with what? No, because they're equal. So since they're equal, we can substitute one in for the other one. All right, so see, we've got 2 is the same as, I wrote this wrong up here. What did I do? That should be 3, right? Like, you already proved it up on step C. And then I did this one right, 2 and 4. Yeah, so since 1 and 4 are equal and 2 and 3 are equal, we can take where 3 is and we can put 2 in there, right? Put the 2 in for the 3, right? Same thing there. So if you're substituting one in for the other because they're equal, that's substitution. Easy peasy, right? Any other questions from this homework? No. Upside down. All right. Well, that's it for today then. Aiden, we'll have you take your test on Thursday. Sound fine? Don't get sick again. Unless you have to, I guess. If you want to come in and take it like tomorrow or something or whatever, you can, but you don't have to. Mm-hmm.